My name is Tanti. On behalf of our team from INRIA Paris, I'm glad to present you approaches and results during our participation in the CLEF HIPE 2020. We were motivated to join this shared task since it relates to our ongoing projects, actually, especially with the National Archive as well as the Paris Hospital in France. Our idea is to reuse the tools built in our environment, which are well documented both for developers and end users, easy to use, easy to adapt to a variety of data, and are applying the latest technology, of course, for name entity recognition and disambiguation. We participated in 2 different tasks on ERC and EL only tasks for English and French, with 2 different frameworks, DELF and entity fishing. DELF is a deep learning keras and TensorFlow framework for text processing, focusing on sequence labeling and text classification. It comes with various pre-trained NER models for English and French, which are trained on various datasets. For instance, CONOL 2003, CONOL 2012. With the support of different deep learning architecture, as well as contextual embeddings, which is Elmo and BERT, DELF wants to re-implement standard state-of-the-art deep learning architecture relevant to text processing tasks. In order to train and evaluate models with DELF, annotated data needs to follow the IOB2 scan. Meanwhile, entity fishing is a machine learning for recognizing entities from raw documents, text or PDF files, and disambiguating these entities against Wikidata. The tool developed by science minor with the contribution of INRIA Paris support English, German, French, Spanish, Italian languages. It uses SMILE as library for machine learning. The disambiguation use supervised machine learning based on random forests and gradient tree boosting, exploiting various features including word and entity embeddings. Training itself is realized by exploiting Wikipedia, while the result include in particular Wikidata identifiers and statements optionally. It provides also REST API services, which allowing clients such as a web browser or server to interact in a very flexible manner. For DELF, it used technology, it used Python as programming language, while entity fishing, it used Java and other tools for developing the interface. Now I will move to the approach that we were using. For the in-ER task, we built models with DELF. However, since the absence of training data for English, it gave us ideas of using external data in addition to those provided by the organizers. For the English model, we use annotated data from Ontonus 5 CONOL 2012 for training and evaluating it with the DEF CLEF English data. As for the French model, we use FTV, annotated corpus, which is journalistic genre corpus from the year 1990. It is manually annotated in 2007 by Sago and the team here at INRIA. We then combine this external data with the CLEF HIPE training data. We use bidirectional LSTM CRF architecture, and also we combine word embeddings, FASTEC, and Elmo. The reason that the choice of the architecture and embeddings is based on the evaluation results that has been carried out and reported by DELF, And you can see detail in our article. Meanwhile, here for the entity linking task, we didn't do much with entity fishing. Actually, in general, we provide tags extracted from the CLEF data and feed this text to the system. Then we extract the result from the recognition and disambiguation pipelines. Even though there are many ways to access the results from entity fishing services, including we can use the API service by sending a request in JSON format. In our case, we use to provide classes and methods as library, and we adapt these methods according to our needs. Now we'll present also the result. In general, our INRIA English and French in INRIA models perform better than the provided baseline, except here, for instance, for the French score for microstreak, we have below the baseline. The baseline here, which is the CRF sequence classifier provided by the organizer. And we have also competitive result compared to other participant system. But of course, in this occasion, I would like to congratulate as well the winner from the La Rochelle, I think, if not, I'm not forgotten, who win the almost all task for the HIPE. We have interesting result with the entity linking only system, which is entity fishing. Actually, it has not developed yet deep learning architecture, but however, it yields it outperform the result even with the team from La Rochelle. So it's quite interesting for us. It's we can give some conclusion that the use of the combination between FASTEC and ELMO, however, is promising, even though many of other participants use BERT. Based on the result, we can see that it's also promising. We have difficulties, especially with the lack of training data, but however, it's not an obstacle because we can use external data. And the challenge for us, we found that by using or combining data from external data from different environments, we will have problems, especially with the class definition, because we don't have the same class definition, and then we don't have also the annotation guidelines. However, we thank the organizer who gave us the opportunity, so we know where we are, and we found many findings in this shared task. Thank you.